Imagine a mission so daring and so amazing that it seems impossible to do it for decades. A spacecraft designed to travel into the heart of the solar system, not only to observe the sun from afar, but to fly directly into its outer atmosphere, the corona, where the temperature rises to levels we cannot fathom. This is the story of the Parker Solar Probe, a marvel of human invention that pushes the boundaries of technology and science. Launched in August 2018, this daring mission promises to uncover the secrets of the Sun, our nearest star, where all life on Earth is. But will this spacecraft, exposed to extreme heat and sunlight, survive long enough to gather the important information we need? And what revelations will be given by its close proximity to our star, the Sun, a fiery ball of plasma at the center of our solar system, holds secrets that have eluded humanity for centuries. Our star's solar winds, flares and magnetic fields have a profound effect on the universe. From disrupting satellite communications to influencing global weather patterns, the Sun's power is irresistible. As technology advances and our reliance on electricity and communication increases, understanding the Sun has never been more important. But approaching the Sun felt like an impossible challenge. What if we could reach within a few million miles of space, where no man-made object has ever been? The Parker Solar Probe is designed to do just that. Could this mission provide answers to questions that have puzzled scientists for generations? And what unexpected problems do you face with this pioneering spacecraft? In August 2018, one of the most ambitious and challenging space exploration missions in history was launched aboard the Delta IV Heavy. The Parker Solar Probe began its journey to the Sun with a specific mission: to explore our star closer than any other man-made object. For decades, solar research was limited to the energy of the Sun's heat and radiation. Probes like Helios 1 and 2, launched in the 1970s, have come close to the Sun, but at a distance of 36 million miles, about the same as Mercury's orbit. Parker Solar Probe, designed to get even closer, just 3.7 million miles from the Sun's surface. For the first time in human history, we are receiving information from the Sun's corona, a region thought to be too dangerous for a spacecraft. The Parker Solar Probe is named after Eugene Newman Parker, a pioneer in solar exploration. Parker was the first person to think about the existence of the solar wind, the streams of charged particles coming from the Sun that travel through the solar system. His pioneering work in the 1950s set the stage for one of NASA's greatest space exploration efforts. As the Parker Solar Probe's journey begins, not only the instruments but the hopes of scientists around the world are eager to unravel the mysteries of our Sun and its dynamics. From the beginning it was clear that sending research into the solar corona would require technology beyond what had previously been developed for space travel. Unlike studies of Mars, Jupiter, or the far reaches of the solar system, Parker must probe temperatures in excess of 2,300 degrees Fahrenheit. It's an amazing technical challenge. The spacecraft needed a shield to protect its delicate instruments from the intense heat of the Sun and allow them to collect data. The resulting solution is a revolutionary heat shield, a 9-foot, 4.5-inch thick plate made of a special carbon composite material coated with a layer of white ceramic. Known as the Thermal Protection System, TPS, this shield is designed to withstand temperatures of 2,500 degrees Fahrenheit and maintain a cool environment inside the spacecraft. Behind the shield, the instruments work in conditions similar to the ground, allowing them to collect data without being damaged by the heat of the sun. In addition to heat protection, the Parker Solar Probe was equipped with solar panels for power supply. These arrays are mounted on movable arms that can be removed and extended as needed. As the probe approaches the Sun, the arrays collapse to avoid overheating. This design allows the spacecraft to survive close flights to the Sun while being powered by solar energy. The Parker Solar Probe's trip to the Sun was not a direct trip. In 7 years, the spacecraft will complete 24 orbits around the Sun, bringing it closer to the star's surface. To do this, the probe will use Venus as a gravity tilter, making 7 orbits around the planet to adjust its course and speed. This allows the probe to gradually decrease its orbit around the Sun, reducing the distance on each trip. The mission of the probe is to fly through the sun's outer core and gather information about the solar wind, magnetic fields, and the mysterious heating of the corona. The corona is a region of particular interest because it is hotter than the sun's surface, reaching temperatures of over 1,000,000 degrees Fahrenheit, compared to only 11,000 degrees Fahrenheit at the surface. This paradox has puzzled scientists for decades, and the Parker Solar Probe is responsible for solving it. Its closest approach, the Parker Solar Probe will travel at a speed of 365,000 miles per hour, making it the fastest man-made probe in history. These launches allow the probe to spend several hours in the orbit, collecting data on solar particles and magnetic fields. After each flight, the spacecraft returns to a safe distance, cools down, and returns its observations to Earth. One of the probe's greatest achievements came in April 2021, when it first passed through the sun's corona. During this historic event, the spacecraft collected images and data from an area of the sun that had never been explored before. The images show streams of charged particles streaming from the sun into space, giving scientists the first close-up view of the solar wind at work. Later next year, in November 2021, the Parker Solar Probe will come even closer, coming within just 5.3 million miles of the sun's surface. During the flyby, the probe observed unusual shifts in the solar wind, S-shaped magnetic fields that twist and turn as they move away from the sun. These changes have been proposed but have not been fully explored. The data collected during the flyby will help scientists understand how the sun's magnetic field affects solar wind patterns and provide clues for predicting daytime storms. Each flyby brings the probe closer to the sun, providing new insights into the behavior of our star. These findings have significant implications for our understanding of climate and its effects on Earth. Solar storms driven by the solar wind disrupt satellites, power grids, and communication systems on Earth. By studying these winds in more detail, scientists hope to develop better models to predict when and where solar storms will occur, potentially giving us more time to prepare for them. Their interests point. One of the biggest mysteries Parker Solar Probe is trying to solve is the temperature gradient in the sun's atmosphere. Although the surface temperature of the sun can reach 11,000 degrees Fahrenheit, the outer temperature can reach 1,000,000 degrees Fahrenheit. It seems counterintuitive. How does the outer layer of the sun heat up the surface? Scientists believe that the sun's magnetic field plays an important role in this phenomenon, but the exact mechanism remains unclear. The Parker Solar Probe was designed to collect data on the sun's magnetic field, allowing scientists to observe the flow of electricity in the corona and heating of the plasma. By studying the origin of solar winds and magnetic fluxes, research can provide missing pieces of the puzzle. Understanding how the corona burns not only solves one of the biggest mysteries of the sun, but also sheds light on how the stars around the world behave. Parker Solar Probe has already made history, and the project is nearing completion. With each new flyby, the probe is bringing us closer to understanding the sun and the forces that shape our solar system. The data it collects will help scientists predict solar storms more accurately, safeguard our technology, and deepen our knowledge of the fundamental processes that govern our universe. Eugene Parker, the namesake of the mission, lived long enough to see the Parker Solar Probe achieve its first major milestones. In one of his last interviews before his death in 2022, Parker expressed his amazement at the mission's success. "It's thrilling," he said, "to know that after all these years, we are finally able to get this close to the sun and learn its secrets." As the Parker Solar Probe continues its journey, we are reminded of the power and beauty of our sun. It is the source of all life on Earth, but it can also disrupt our world in ways we have yet to understand. With the Parker Solar Probe leading the way, we are one step closer to unlocking the mystery of our home star. Parker Solar Probe's mission is unique. From its daring design to its uneventful journey to the sun's corona, this spacecraft is a symbol of human ingenuity and endurance. As it continues to collect data on the solar winds, magnetic fields, and the superheated corona, the research is helping to solve some of the mysteries of the sun. This data is not only important to advance our understanding of the sun, but also to protect our technology and infrastructure from the sun's destructive power.